Good day everyone! For this video, we will discuss about the unit circle. Our agenda for today is to identify what a unit circle is, how to identify if the point of the unit circle is on the circle itself, inside the circle, or outside the circle, to learn about the coordinates of quadrantal trigonometric points, and to learn coordinates of trigonometric points pi over 4 and its multiples. Before we start, what is a unit circle? Unit circle is simply a circle with a radius of 1 unit. And we all know that radius refers to the distance from the center to any point of the circle. We must keep in mind that a circle is a unit circle when the center is at 0, 0, and the radius is equals to 1. Moving on, let us now learn how to identify if the point of the unit circle is in the circle itself, inside or outside. To identify the location of the point of the unit circle, we can use this equation. For our first equation, we have a given of 17 over 102 and negative 36 over 102. To know the location of this point, we simply need to substitute the values of x and y to the equation x squared plus y squared is equals to 1. So 17 over 102 squared plus negative 36 over 102 squared is equals to 1. Using our calculator, the answer is 0.10, and with this, we can conclude that the point is inside the unit circle for the reason that the value is lesser than 1. We should always remember that if the value is exactly 1, it is in the unit circle itself. However, if the value is less than 1, the location is inside, and if the value is greater than 1, the location is outside the unit circle. Let us try another example. Given B, points are 11 over 3 and square root of 13 over 7. Again, let us just substitute the given points to the equation x squared plus y squared is equals to 1. After inputting 11 over 3 squared plus square root of 13 over 7 squared to our calculator, it gave us a sum of 13.10, which we can tell that it is not equal to 1. The value 13.10 is greater than 1, therefore we can conclude that the location is outside the unit circle. Now that we know how to identify the location of the points in a unit circle, let us now proceed to our next agenda, which are the coordinates of quadrantal trigonometric points. I will give different equations and I will explain each of them. First, let us discuss the equation P. 2n times pi is equals to 1 and 0. As we can see, there is a given 2n, and when we multiply any integer to 2, it will give us a value that is an even number, and with that, we can tell that its corresponding coordinate is 1 and 0. For example, 112 pi. Since 112 is an even number, let us prove if its corresponding coordinate is really 1 and 0. To prove that, we simply need to divide 112 to 2 so that we can find out the value that we have multiplied to 2, which gave us 112. And 112 over 2 is equals to 56. To prove if it corresponds to the coordinate, let us simply substitute 56 to the equation. 2n times pi. So let us just input 2 times 56 times pi in our calculator, and it will give us a value of 112 pi. With this, we can conclude that its coordinates are 1 and 0 for the reason that it is an even number in the whole number.
For our next equation, which is p, 2n plus 1 pi is equals to negative 1 and 0, we have noticed that an additional 1 was added to 2n, which will give us an answer of 3, and any even number that is increased to 1 will give us a value of an odd number. With this, we can conclude that the value must be an odd number and a whole number, so it could satisfy our given equation, which is p 2n plus 1 pi is equals to negative 1 and 0. Basically, it is kinda similar to our first equation, it's just that the value must be an odd number and not an even number. For our third equation, which is p 2n plus 1 half pi is equals to 0 and 1, we have noticed that there is a value of 1 half added to our 2n, and with this, we can conclude that the value that corresponds to 0 and 1 is not a whole number anymore, but a fraction. However, there are two equations that involve fractions, so for us to identify if the given value suits our third equation, let us try this example. Given the value of 29 over 2, we can notice that it is a fraction, and for us to identify if it suits the equation, let us convert the value first to mixed fraction, and 29 over 2 in mixed is 14 and 1 half. And with this, we can conclude that it suits the equation because 14 is an even number. Moving on, we need to convert 14 and 1 half to the equation. Let us check if it gives us a value of 29 over 2 pi for us to prove that the value corresponds to the points 0 and 1. So 14 divided by 2 is 7. So let us simply put 7 in the equation and it will become 2 multiplied to 7, and then let's add the 1 half times pi, and it gives us a value of 29 over 2 pi. With this, we can conclude that it corresponds to the point 1 and 0. Let us now move on to our last equation, which is p 2n plus 3 over 2 pi is equals to 0 and negative 1. In this equation, we can notice that there is an additional fractional value that was added again to our 2n. To determine if the value suits the equation, we just need to convert the given fractional value to mixed fraction, and the value should be an odd number. If we convert it and the value equates to an odd number, therefore the value fits the equation and it corresponds to the points 0 and negative 1. We have just covered the topic about the coordinates of quadrantal trigonometric points, so let us now move on to our next topic, which are coordinates of trigonometric point pi over 4 and its multiples. To simply explain the topic, if the coordinates are both positive, the points are in quadrant 1. If the x-coordinate is negative and the y-coordinate is positive, the points are in quadrant 2. If both coordinates are negative, the points are in quadrant 3. Lastly, if the x-coordinate is positive and the y-coordinate is negative, the points are in quadrant 4. To identify which equation to use, the denominator must be 4. For us to identify if the equation suits on the first or second, the value must be an even number, and let us simply look if the number added was 1/4 or 3 over 4. We use the first equation if 1 over 4 is added and the second equation if 3 over 4. Moving to the third and fourth equation, the value must be an odd number, and we need to look if the value added is 1 over 4 or 3 over 4 upon converting to mixed fractions. We use the third equation if 1 over 4 is added and the fourth if 3 over 4. And that's all for today. Thank you and hope you have learned something in this discussion.